Off the Wall Productions is proud to present Voices of the Methow. This is a series of conversations with interesting folk in and around the valley. On February 4th, 2020, the Methow Conservancy hosted Biologist Scot Fitkin and his daughter Amy for a presentation on local climate change species indicators in the Methow Valley. This was held at the barn in Winthrop, Washington. Since it was a PowerPoint presentation, I've added voiceovers where I thought it necessary. They both did such a great job in presenting their material, I believe you will get a lot out of it without the pictures. I found this presentation very informative on many different levels and easily decided it was worth the effort making this available as an audio recording. My thanks to the Conservancy and to the Fitkins for allowing me to put this recording on Voices of the Methow. We start with Johnny Duguay from the Methow Conservancy welcoming everyone.
Hi, welcome. Welcome to the Methow Conservancy's first Tuesday event with Scott and Amy Fitkin talking about climate change indicator species. My name is Johnny Duguay and I am the Methow Conservancy Stewardship Associate. We have a ton of great content and information coming up, so if you don't get our e-news, go ahead and go to our website, methowconservancy.org, and sign up for e-news and check out our website. You can see all sorts of fun stuff going on. So Scott is our district's Washington Department of Fish and Wildlife biologist, and he just told me before you guys all got here that he's been working in the Methow Valley for 30 years, which is longer than I've been alive. He's probably a familiar face to a lot of you guys, and if you haven't heard him speak or seen him flying around above you in a helicopter counting deer, this is a great opportunity tonight to hear from him and also hear from his daughter Amy, who is following in her father's footsteps and also forging a path of her own. She is really, truly a thoughtful and compassionate environmental educator. I've had the pleasure of working with her in some of our field experiences. She's studying at Western Washington University, the Huxley College of the Environment. She's getting her master's degree in environmental education with a focus in ecofeminism. And I'm sure her dad is learning from her too, just as she's learned from him for many years. I'm very excited to hear from them. They are super thoughtful, energized, enthusiastic people who care for the Methow. And we look forward to learning about climate change indicator species from them tonight. Thank you guys.
Everyone. Thank you so much for being here tonight. Really glad to see you're here. Like Johnny said, my name is Amy Fitkin. I am doing my master's degree in environmental education with a focus in ecofeminism. Before that, I did do biology. That was my main focus in undergrad, and I worked in the field in wildlife biology, really following in his footsteps. However, I decided to take a slight left turn and go into the education field, and I am super passionate about it. I'm passionate about three things: the environment, education, and this community. So this is a really big blessing to be here to speak to you all tonight. I also want to start us off by humbly doing a land acknowledgement. We acknowledge that we are on the land of the indigenous Methow people. While a land acknowledgement is not enough, it is a good step in the right direction to decolonize and to remember the people who still live in this land and did before. I think it's a really good thing to do for visibility of the indigenous people. So I just welcome everyone to think about that as we move forward in this presentation. And now I'm going to pass this off to my dad.
Well, I too want to thank you for coming out tonight. I kind of did expect a big crowd, given that anytime you put a really charismatic animal like a lynx on a flyer, people tend to show up. So, I appreciate you coming out. Well, hopefully you'll enjoy this. I think if nothing else, there'll be a lot of really pretty pictures that'll be enjoyable, but I think you'll learn something too. This, first, let me back up. I want to thank the Methow Conservancy both for this opportunity, but for hosting these kind of talks in general. I've been to many, many over the years and learned a lot, and I think it's just a great resource for a small community like this. This topic is huge. Climate change indicator species. Could do a talk on one species individually easily. And so this is not going to be a real deep dive. It's going to be more of kind of an introduction into some of the general concepts of climate change and how they might affect species, and hopefully kind of stimulate you to learn more. And there will be a few links at the end of the talk you can check out, or just go online and Google any of this information to get tons of stuff that you can research. So let's see, I think Amy's starting. I'll come in second fiddle a little bit later.
So, welcome to the Anthropocene. Who here has heard the term Anthropocene before? Yeah, so Anthropocene, let's break it down for a second. Anthro, meaning human, right? And Pocene, or scene, meaning a new epoch. So epoch is what delineates a geological time frame. And so this term is not official. We are officially in the Holocene, right, as a geological epoch. But this term is really contested between environmentalists, climate scientists, and geologists. What it means is that humans have had such great impact on this planet that it is changing the environment and climate just by our activities. We have changed things at the same scale as a glaciation event, a volcanic eruption, a meteor. So we are making a very big impact on this Earth. So I just want to start this presentation off with this lovely term. I also like to emphasize that it doesn't necessarily always mean a bad thing, right? So we have the power to make change, but we also have the power to make change in a positive way. So I just want to start that off in a slightly more positive note. I don't want to doom and gloom you all in the first 20 seconds. All right, and so this term, the Anthropocene, as we think about it, sometimes we wonder, when did humans start making their impact? Was it when this stuff started getting developed? Or was it when the hunter-gatherer stage of humans moved into the more agriculture stage, where we were joining in communities and living in large groups, right? So to do that, we're gonna look at this time scale. So this is what I was talking about when I was talking about an epoch. Look at these huge blocks of time. Look how small this Holocene is. The Holocene started almost 12,000 years ago. And so we have only been in this epoch for 12,000 years, and we are already making a huge impact. So that is what we need to emphasize here, is the scale and the rapid rate of the change that we are making is absurd. So this is a little graph that shows the temperature over time. And so who can guess what happened right here? Agriculture happened right about here. So this is actually about where the beginning of the Holocene is. So this is when agriculture really took hold of the human species. So this is the first industrial revolution, way back in the 1700s. And from here you can see there's a rapid increase in things like CO2 emissions, temperature increase, etc. And then to go even further, we have here, the third industrial revolution began in 1950, right, with our technology. And this is where we see, I believe, in my opinion, I'm gonna do a caveat there. In my opinion, this is our biggest dramatic increase we see right here. And this is looking at temperature as well. So I'm gonna kind of focus on 1950 on when we talk about climate change that we see today. For example, world population. This is 1950 right there. Look at that increase. Carbon dioxide, 1950. Look at that increase, right? You just can't deny it. It follows the trend. All right, and then one more right here. Look at this. This line had not been crossed for carbon dioxide. 1950 happened. And I thought that was really interesting, that as humans, we've developed amazing technology. We cannot deny that. However, we're doing it without limits, and it's making a significant impact on our environment. Climate change is a human issue. We caused it, this climate change in our Anthropocene, as it relates to the Anthropocene. However, we also have the power to make changes for the better. So, I know it's really hard to see pictures like this, right? We look at pictures of polar bears and it's really sad. And we look at it on our computers with our news feeds, our Instagram posts, our BBC channel shows, our Animal Planet, right? We can look at it from our couch and we say, that is so sad. I really wish that it wasn't happening. I really wish that I could have seen the Great Barrier Reef. That was one of my bucket list items. However, ocean acidification is happening and I don't know if I can anymore. So it's really sad to look at it. However, I want us to take a few steps back and think about our place here in the Methow. Let's bring it place-based. Let's look around us and see how human health and the health of the environment is being affected by climate change here in our community. That's kind of what we're going to go with today as we move forward. We are going to think about the Methow Valley as a frontline community. A frontline community is a community that experiences climate change first, right? So these communities will be places like rural, low-income, and indigenous communities. So they experience the effects, whether that is going to be with their agriculture, lack of rain, right? Hotter summers, wildfires, it's going to affect agriculture, it's going to affect recreation, it's going to affect resource dependability such as lumber, etc. Thinking about that, we are going to see things in this community, right? We are a very resource dependent community. And so knowing that as we move forward, we can also look at our other species that are around us. And so today we, unfortunately, like my dad said, we can't focus on everything, single species. That would take hours. We are going to focus on specifically, I would like to point out these two factors. So we have more precipitation falling as rain rather than snow, as we've been seeing these last few weeks, couple weeks, right? So we're seeing more rain rather than snow. We're also seeing a loss of key habitat due to wildfires. I'm sure we're all really familiar with wildfires in this area. It's really affecting us and our health, as well as a lot of the health of our more than human species in this area. So let's look at specifically high country species. These are going to be the animals and plants and fungi and bacteria that live in the alpine, subalpine regions. We're going to focus in on this area because it's an area that we have a lot of conclusive data that we can pull from. It's a good place to look at as a model when we look at other animals. So we're going to focus on 3 species today. I am going to, at this point, pass over to my dad so we can learn about really cool animals and you can look at pretty pictures.
So do I have to tell you that I'm proud? Yeah, as Amy says, we're going to focus on a few specific critters. However, I want to give you a sense of the wide variety of taxa, different types of animals, all of which are going to be affected by climate change to one degree or another. Some cases might be positive, some cases be difficult to see a change, in other cases it could be pretty significant. So just keep in mind that the effects will vary by the species, the life history of the animal, how it lives its life, and the place that it lives in. For instance, if you're a species like a mountain goat that's a specialist, adaptation might be a little tougher than if you're a wolf and you are a more generalist species and occupy a variety of different habitats. And I wanted to back up and point out, I did my very best to include almost every photo in this presentation is local, i.e. North Cascades, and most of them are pretty Methow-centric. There's 1 or 2 that I had to steal from other places, but by and large, these are local photos, which is always a lot of fun. So, similarly, if you're a sharp-tailed grouse and you live in relatively small patches of fragmented habitat, you might have a tougher time adapting than a black bear that's living in large blocks of contiguous habitat. Or if you're a tiger salamander and you're pretty much tied to small ponds and vernal pools in the shrub steppe and you don't move very fast or very far, you're going to have more trouble adapting than a Clark's nutcracker that can fly between different ecological regions if it needs to. One of the factors that affects how animals are going to be able to adapt is what biome or what life zone they live in. And I want to focus on what I'm going to call the high country, for lack of a better term, and I'm going to do that because this is where change is occurring the fastest. This is where the temperature is increasing the fastest. This is where we're seeing the biggest changes in our snowpack. So I'm going to define the high country as being a combination of 3 sort of interrelated life zones. The first one being the boreal forest. And what I mean by that is that forest cover that's roughly, say, about 4,500 feet, depending on where you're at. And it's lodgepole pine, it's Engelmann spruce, subalpine fir, and subalpine larch. That is the middle fork of the Pasayten, I think? West fork of middle fork. Subalpine. So this is sort of the upper half of that forest zone where you get a mixing of the forest community and these beautiful meadows with the wildflowers in the summer. This is probably my favorite place on earth, is the subalpine environment in the mountains west. And then the alpine. So at or above tree line, essentially, it's our version of the Arctic tundra. The plants are adapted to growing in really harsh conditions with really short growing seasons. And on the whole, this is a winter-dominated landscape. Deep snowpacks. In places we've got permanent snow and ice year-round. It's an area that has winter for 6 to 9 months of the year, typically. And I decided, as we talked about, there's just a million different critters we could talk about, but these 3 come to mind for a couple of reasons. One, they're animals you hear a lot about with respect to climate change. They all occur here locally, And the two carnivores we've actually done some research on, so we have some interesting data that we can share with you. And so we're going to focus on how climate change may impact these three species in different ways or in different degrees. And I'm gonna say that pika, wolverine, and lynx are going to be increasingly affected in that order. And we'll jump into pikas first. And I'm going to call the pika the specialized generalist. And what I mean by that is it lives in a specialized niche, i.e. the talus slopes, but it lives in that talus across a broad elevational gradient from, say, below 1,000 feet west of the crest to 8,000 feet here on the east side in places. And it lives in that talus for a variety of reasons, one of which, or a primary reason, is to get away from predators, with one exception, and that would be this animal here. It's just as adept as getting into those talus spaces as the pika is. And in fact, that photo was taken in a pika colony. That animal was looking for dinner.
And that animal looking for dinner is a short-tailed weasel, also known as an ermine.
But, charismatic, world's cutest animal, potentially. Because of the niche it occupies, this is its range in the west. It's found in the mountainous country where you have talus slopes and where you have at least somewhat cooler temperatures. But this is an animal you've probably heard in the media talked about as a climate change indicator, because in this portion of the range, kind of the southwest portion particularly, it tends to exist on these sky islands. What I mean by that is little mountaintops or ridge tops where it's isolated from other patches of habitat. And we've been seeing local extirpations or local extinctions of this species in some of those areas. So people have been paying a lot of attention to it with respect to climate. A little taxonomy before we move further. Unlike these three animals, the hoary marmot, the Columbia ground squirrel, and the golden mantle ground squirrel, all of which occur often in the same places pikas do, pikas are not a rodent. They're a lagomorph. They're a member of the rabbit family. And the reason I bring this up is because it affects their ecology significantly. Specifically, they don't hibernate. Unlike those other critters, they've got to cache food for the winter. They've got to feed themselves all winter long. They're small animals, so they've got a fairly high metabolism. And they go about that by caching the summer bounty, typically under rocks and other structures they find. And so, I like to think of them as the adage for make hay when the sun shines, because that's literally what they do all summer long. They're running around, gathering stuff, stuffing it under these rocks, usually where there's some sun exposure, so it'll dry out, and then they'll pull it back in farther for the wintertime. And they get pretty creative. So, I don't know if you can tell, this is a pika cache. I found this log, stuffed it full of stuff, and in the winter, I'll probably pull that all down into the rocks. So another interesting thing about pikas specifically is they are pretty temperature sensitive. And in fact, prolonged exposure to temperatures above 78 degrees can actually kill them. And 78 is not all that hot. You think about our Methow summers. But these guys, they're living, like I say, across a wide elevational gradient. So in some places, they're exposed to some pretty high temps. And they can mitigate for this to some degree by getting down into the talus where it stays cooler even on the hottest days. But there's limits to that. If you're living in a place where it gets to 90 or 100 degrees in the summer, and you're having to spend all your time in the talus to avoid that heat, you're not going to have enough time to forage. And so that may be one of the reasons why in places like, this is a picture of Great Basin National Park on the right, on some of these sky island ranges in Nevada where pikas are winking out, they just might not be able to forage long enough anymore. There's a variety of other factors involved, but that's one of the theories. And like I say, there's a bunch of complex variables that play into pika habitat: maximum summer temp, minimum winter temp, moisture, food availability. But the long and short of it is, by documenting occurrence, they were able to chart what they thought was essentially occupied range back in 1955. In 2010, went in and did a bunch of survey work, and these red squares or red crosses indicate where colonies had disappeared. And then moving forward, their prediction is by 2030, the white color is essentially the pika habitat. It's going to decline noticeably, and even more so by 2050. And that reminds me to tell you something. So I'm going to focus on sort of my professional judgment about what I think some of the effects might be on these animals for the next 30 years, which, give or take, is probably my lifetime, And it's far enough out to where we kind of feel like we think we kind of know what's coming. And as you get farther out, there's more uncertainty as first of all, what our climate might do and how animals might react to that. So I'm going to kind of stay focused on about a 30-year time frame. So in Washington, like I said, we've got pikas right now spanning a pretty broad elevational gradient, and we're fortunate in that because we live where we do, our climate's mitigated by the marine onshore flows. Our temperatures are not as extreme. We do have this variety of habitats, and so I think pikas are, at least in the next 30 years, are going to do reasonably well because they've got some room to adapt. Now, that doesn't mean there may be site-specific areas where they struggle, and this is one example I thought I might bring up because it's local and you can experience this if you want. This is Black Lake. This is the east shore of Black Lake, and there's a lot of talus, a lot of pikas there typically. I usually go in there once a year to survey for loons, and I frequently will hear pikas if it's not too hot out on these talus slopes. But because they are so exposed, I just wonder with climate change if eventually that site's just going to get too hot and pikas aren't going to survive there anymore. Let's move on to a really charismatic critter, the wolverine. I'm going to call the wolverine the generalized specialist, so sort of the reverse of the pika. And he's the wolverine, he or she is the lord of the snowy realm. They stay high year-round, and they're really adapted for this snow-covered environment. And their specialization is that they're living in this high country, this really snowy world. And the generalized part of it is they're using all of it. They're using the forest, the subalpine, the alpine. They're going everywhere within that high country environment. And you can see it in their morphology, or just the way that they're put together in terms of their snow adaptability. They essentially have built-in snowshoes. This is an animal that weighs, from our experience, anywhere from about 18 to 33 pounds. And yet it's got a foot the size of a cougar, or even a little bigger than a wolf. And so it's able to float on the snow reasonably well. It's got built-in crampons, sharp little claws. And it's got a fur parka that is not only frost-free or frost-resistant, but keeps the animal thermally neutral down to minus 40 degrees. So, astoundingly well adapted to the snow. And so when researchers started thinking about this critter, they thought, well, how do you predict wolverine habitat? I mean, it's such a snow-adapted animal that one idea was that, well, maybe looking at snow cover was the way to do this. And so Jeff Copeland and others developed what we call the bioclimatic envelope model. And it's essentially looking at where snow persists well into the spring, say mid-May. And if you do that and you figure out where that is, that's sort of a rough guide of where you might expect to have wolverines. And as it turns out, that matches up pretty well with where we currently have animals. So those red polygons are places where right now we have wolverines on the landscape. The two most robust populations are here in the Northern Rockies and here in the Washington Cascades. There's probably a few here in the Yellowstone ecosystem. There was one that dispersed all the way from Idaho to the Sierras a few years ago. Last time I checked, it was still there. They get it on a camera every so often. And the Wallowas in Oregon have had wolverines. It's kind of unclear as to whether or not they come and go or if they are persistent there. If you look at the historical documentation, and these are records that are verifiable, so like photographs, carcasses, that kind of thing, they match up again really well with this snow envelope model. So wolverine study, I had the good fortune to partner with John Rohr at the Forest Service on a wolverine project here for 10 years, and we managed to handle, we got 14 different animals on this project. There were like 42 individual captures. And, it's difficult work at times, as you can tell. So a couple of quick anecdotes, because these are fun stories. The picture on the left represents a time when we had a series of just massive storms come in. We usually try to close the traps before that happens because we know they're going to be tough to get to. We don't want an animal trapped inside of one of the traps. So we didn't get there in time. Storms came in. This device here sends us a signal and tells us that the trap is closed. So of course, towards the end of this series of storms, we get the signal that the trap is closed. Like, oh, we got to get there and make sure there's not an animal in the trap. No way were we going to get there on foot or snowmobile. So a couple of us had to fly in a helicopter real quick.
Well, I'm going to break in here for a minute and mention that the PowerPoint slide Scott is referring to is showing an impressive amount of snow needing to be removed, something like a 15-foot by 15-foot square, 10 feet deep, to get access to the trap.
And the only thing we could see when we got there was like the last maybe 12 inches of this pole sticking out of the snow. It was just a flat white spot. You wouldn't have even known a trap was there. Fortunately, I knew where it was, told the chopper where to land, and several hours later, we dug down. We're about maybe 3/4 of the way down there digging that out. And there was no animal in there. But, it was just an example of sometimes the challenges of working with these wide-ranging elusive carnivores. Another fun story, so picture on the right. Because captures were fairly rare, only a few a year typically, you wanted to leave the traps open as long as you could. So one Christmas, we were kind of hemming and hawing. Should we leave them open during the holidays? I was like, yeah, let's leave them open. A few of us will be in town. Chances of catching one on Christmas are low, right? Christmas Eve, signal goes off, Wolverine in a trap, and there's only 3 of us on the crew in town. So I was like, okay, conscript the family, wife and daughter, get your gear, we're going out Christmas Eve to catch a wolverine, and that's what we did. We put a radio collar on it, named it Dasher, turned it loose, life was good. So, the Wolverine, you could get John Rohr up here to do a whole hour-long Wolverine talk. It'd be really interesting. I encourage it's been long enough now, maybe that's a talk we need to do again. In any case, I'm just going to share a little bit of data with you. This represents the telemetry locations we got from our wolverines. The blue is that climactic envelope I'm talking about. And look how well those dots line up with that snow cover map. That wolverines are sticking to the snowy country. There's a few exceptions. One that's kind of interesting is the Twist River. And I think it's because it's a narrow, steep valley in between a couple of blocks of nice habitat, and so the animals come down and cross through there every so often, which was fortunate for us because that's where one of our traps was, and that was the easiest trap to get to, so that was nice. All right, so we talked about the fact that they're so well adapted to snow, but why? I mean, what is the advantage there? Well, one of the advantages is if you're a female with kits and you put a maternal den in the snow cover, it's a pretty safe place to raise your kits. You got a deep snow layer covering you up that protects you thermally and protects you from predators. And as of a few years ago anyway, there was a 98% match between the known wolverine den sites and the snow model. So again, pretty amazing data. So here's an actual den from the North Cascades. This is a den of a female we named Xena, warrior princess. She had quite the attitude. This is me at the den hole. Didn't really know where it was, almost stepped right into it. And it, great big mound of snow, really deep snow, not super surprising. But when we came back in the summer, this is what it looked like, which was pretty cool because what happens is these animals find these spots where they're going to have this nice little warm, dry spot underneath the snow. So there's like what we call an interstitial space they can get into.
Scott's slide is showing a summer picture of several large boulders stacked together with some big gaps, providing access to shelter under the rocks.
Why else, maybe, then would you want to be up high in the snow in the coldest spots? Well, another reason we think wolverines like it up there is because they can do what we call food caching. And this is especially true of the maternal females, the females with kits. In the late summer and into the fall, when they catch prey, they can stuff it down into some of these permanent snow fields or deep cracks in the talus, and it'll stay essentially fresh into the winter. So later on, when they've got new kits in the den, they don't have to go as far to find food. This was summarized really well in a comic strip done by our own Eric Brooks here in the Valley, who's in the audience tonight. He's quite the artist and book illustrator. And so this is the refrigeration zone theory. Presents a food-based correlation between wolverine habitats and persistent late spring, early summer snowpack. And that's the mom wolverine handing kit some sort of goodie, some deer leg or something. And this is a strip he named Fact versus Lore with Fitkin and Rohr, Wolverine scientists. And I'm saying to John, amazing John, this husky ice cream is as good today as it was in January. Caching food in cold structured microsites is a boon to both pregnant females, newborn kids, and scientists on midsummer day hikes. So Eric's ridiculously talented, and yes, it is the pinnacle of my career to have been immortalized in a comic strip. So, another reason why wolverines may spend so much time up here in the high country is in the wintertime, a lot of our other carnivores are not there. They're just not adapted to that kind of deep snow, and so they move out of those areas. So some of our other common critters here, these guys are pretty much down in the lower to middle elevations in the winter. So the wolverine's got it more or less all to himself up there with a couple of exceptions. Okay, we know why maybe they're up there, but how do they do it? I mean, how do they survive in the winter when there's 10, 15 feet of snow on the ground? Well, they do it by covering ridiculously large areas. So females, for instance, 200 to 700 square miles. And that variability reflects when they do and don't have kits. Like, John can correct me if I get the numbers a little wrong, but I think one year when Xena didn't have kits, her home range was about 700 square miles. And then when she had kits, it was down around the 200 to 300 square mile range, which is still big. Some of our males were ridiculous, over 1,000 square miles. And just to put that in perspective, so 700 square miles is about 500,000 acres, which is a little smaller than the whole Pasayten wilderness. But that's how they make a living. They cover a lot of ground. So if there's anything to eat up there, they have one of the best noses in the animal kingdom, and they're going to find it. Now in the summer, they're basically going everywhere and eating everything. They're more active hunters in the summer. They're preying on a lot of our smaller mammals and birds. Hoary marmots, we think, are particularly important. They're a pretty large food item. They put on a lot of fat in the summer. So, if you're a wolverine and you get one of these, that's a pretty big score. In the wintertime, they're still covering these huge areas to find these resources. And so on the left is a map of one of our males named Chewbacca, because he almost chewed his way out of a trap one year. John sent me the information. So the red is like a path that he covered over a few days. And to give you some perspective, here's Mazama, here's Washington Pass. This is well over into the park, South Pass. And I want to say that was like 10 days or something like that. He did that in. And he's just going straight up and over. They don't go around. They just go straight up and over. And they're able to take advantage of things like goat carcasses and not just eat the tasty bits, but eat the whole thing, right down to the bones. And they can do that because they have ridiculously strong teeth and jaws for their size. They can actually crunch up bones. And one quick anecdote, if you read the book, The Wolverine Way, the author describes a case where they did a necropsy on a wolverine that I think was killed in an avalanche. And when they opened up the stomach, it was just like a sack of bones. They had just eaten the carcass, bones and all.
The book Scott's referring to is Douglas Chadwick, The Wolverine Way.
So wolverines and climate change. We talked a little bit about their ecology. How is climate change then going to relate to that? Well, as we talked about, we're going to have less snowpack in the Cascades. That, as we discussed, will likely affect their denning habitat and their food caching habitat. So my prediction would be that ranges, right now, pretty much all of that snow model habitat that you see indicated here is occupied to some degree by wolverines. They've pretty well colonized the Cascades at this point, the Washington Cascades. We've got reproducing animals way down south here, so they're fairly well connected. My prediction would be that they're going to shrink back a little bit into some of the places that are going to hold a little more snow longer into the year. I think they'll adapt to that okay because there's really good dispersers. I think they'll make the travel between those areas fairly easily. And one thing to note, so a lot of the climate models predict most of the glacial ice and snow in the western United States south of Canada is going to go away, but this is likely the last place that's going to hold glaciers here in the lower 48 states. And as part of this discussion about what some of these impacts might be, we're collaborating with a variety of different agencies and organizations to do a little long-term monitoring. On the right is an apparatus that we use to get the chest blaze photo of an animal because that's a unique signature of an individual, just like, say, spots on a whale's tail, that kind of thing. And then we can also use baited sites with these strips that collect hair for DNA. And I love this picture because here's a couple of members of the weasel family together, and wolverines will frequently travel together. That's part of a bigger talk. If you want to learn more about wolverines and just read a really engaging book, I recommend The Wolverine Way, written by that man right there, Doug Chadwick. Excellent read. Let's move on to our third species, the Canada lynx. And this is the true specialist of the three we're going to talk about. And it's specialized in that it's really found essentially just in the boreal forest, and it eats almost nothing but snowshoe hares. Like, it's not uncommon in lynx range for a lynx's diet to be 75 to 95% snowshoe hare. And it does that in areas that have deep, soft winter snow with an emphasis on the soft, and we'll talk a little more about that. Again, like the wolverine, the snow adaptations in this animal are pretty obvious. That the first thing you notice when you handle a lynx is the enormous feet. Look at these feet. It's clown-like almost. And this is an animal that weighs, I don't think we had an animal over 30 pounds. I think our lynx that we captured ranged from maybe the high teens to the mid to high 20s. It's got a foot at least as big as a cougar's, with only 20% of the body mass. So, this thing floats on the snow pretty well. It's also got these long hind legs, and like any animal adapted to the cold, it's got really soft, really dense fur that's just amazingly cool to feel. And what I want you to watch in this video is watch how this is on a day after a capture with really soft snow. Watch how this animal just sort of floats on top of the snow. So this animal needs a pretty specialized environment, and as a result, its range is pretty restricted. In the U.S., there's this population here in the North Cascades. The Northern Rockies has a decent population. Within the last decade or two, they've come back a bit in northern Minnesota and northern Maine. And then there's a reintroduced population in Colorado. But that's pretty much it. It's a pretty limited distribution south of the 48th parallel. Here in Washington, to be more specific, this map represents what we think was probably historical lynx range, anything in it with a color here. This is the Idaho line. This is the Okanagan. This red dash line indicates where we think lynx now occur currently. So pretty limited. Well, why the specialized ecology? Well, we talked about this with wolverines. A lot of these other animals are just not up there in the wintertime, in that soft, deep snow. And so they're able to exploit that niche where these other carnivores can't get to. Here's an example of another carnivore trying to get a snowshoe hare. That's a marten. There's no way this thing's going to catch this hare with that kind of a head start. Gallant effort, but it's not going to happen. However, this critter would.
On the PowerPoint screen, Scott is showing an outstretched lynx and a snowshoe rabbit and showing the similarity between the two animals.
And I threw this in there because I want you to look at the shape of this animal and the shape of this animal. They're really similar. If you see a skeleton of these two side by side, other than the head and the teeth, they look almost identical. They got these huge feet. This is actually part of the foot. The ankle's actually up here. Rabbits the same way. They're both designed for the snow. So climate change in lynx. What are we expecting? Well, again, you saw that lynx are occupying a much more reduced part of the high country than, say, wolverines are. So they're already pretty limited in their distribution because they're tied to those areas with the soft snow, and we're expecting more freeze-thaw. So that's going to shrink even more. It's going to let things like cougars move up higher, and they're going to lose that selective advantage they have in that winter environment. The other big thing affecting lynx has in the past and is still currently and is expected to are these large landscape-level wildfires that we're having now. And they're increasing in not only in their size, but their frequency, and perhaps most importantly, their severity. This is a shot, that's Black Lake. You're looking into the Pasayten. A lot of that grayish, brownish stuff that no longer has trees was once one big giant block of lynx habitat that is no more, at least in the short term. So this has serious implications for lynx. It's not that they're not fire adapted. In fact, the environment that they've evolved with is a fire-adapted landscape. It's just that it typically burned on a fairly long cycle, like maybe 80 to 100 years, and it didn't necessarily burn quite as hot or in quite as large a patch as we've been experiencing lately. So typically on a landscape, you had a mosaic of cirro stages, and so lynx always had some areas to go at any point in time. But things are changing rapidly. So here's some examples. So this is from 1990 to 2000, these are the fires we had. I would argue that actually during this time frame, that was probably less burning than we might have expected pre-human settlement, because we were still putting out fires really effectively at that point. Then we jumped up 10 years later, and fires really started to take off here. No matter what we couldn't stop a lot of these fires, and we started to burn lots of lynx habitat. And now, as of 2017, we burned even more. This one nice patch of habitat here is now burned, and so we've lost a connection there. This does not show, this map, the two most recent fires that burned more lynx habitat yet. So all in all, we're somewhere in the neighborhood of 53% of our lynx habitat is burned just in the last 25 years, and 34% is burned moderate to high intensity. We do have some data on these animals here. We also had a lynx project that ran concurrently during a portion of the wolverine project. We radio-colored a number of animals. And the primary reason for the study was to really look at how lynx were adapting to this changing landscape with fire. So the take-home message is they're not really using the fires much. They're using the edges. They're finding the old burn that's coming back. The smaller burns, they're able to use a little bit more, but they're really avoiding the burns for the most part. What I want you to see here, though, we think we're already seeing indications of climate change effects. And if you look at the dots, or the circles on the left, those are places that were kind of at the edge of lynx range, or the lower elevation portions of lynx range, where in the old days, for me, old days is like the 90s, we were still getting lynx detections with some regularity. We just were in the midst of doing a fairly range-wide lynx survey, and to date, we're not picking up lynx in those same places. And the other take-home message is, we're like maybe 3 big fires away from losing most of our lynx habitat. Now, it's not all bad news. So burns are not poor habitat forever. Back in the day, we used to think it took maybe 20 years for a piece of ground to come back and become suitable habitat again. Kind of. It's probably going to take a little longer in most places. Carmen Van Bianchi, I don't know if Carmen's here tonight, but she's a local who did her master's on lynx. And what she found in examining some of these burns is 20 years out, you had about 30% of it was coming back really nicely. About 30% was not very good, and 40% was somewhere in the middle. So these areas will come back. They will provide snowshoe hare habitat again, which then in turn means it's lynx habitat. In Okanagan County here locally, we're kind of set up to bring a lot more lynx habitat back online in the next decade or two. If you look here at the list of fires, this date is 20 years out from when they occurred, and so we're set up to start bringing more lynx habitat online. The question will be, how much burns in the interim? Wanted to touch on, we focused on those 3 species, kind of various levels of threat, but there's a lot of other critters that live in this biome or this life zone that are at risk, and some of them you might not even have heard of because they're pretty rare and they're not easily seen, but they do occur. So just to point out a few, this is a boreal owl. This photograph was taken in the Rainy Pass area. So they're around, but again, they're living up in that high forest, and as that environment changes, we're not really sure what's going to happen. Now, climate change is not all bad news. There are probably going to be some winners, or at least some that break even. To go through a couple of these, this is an interesting story. California ground squirrel. Didn't occur north of the Columbia River until, I don't remember how many years ago, but somehow made it across the Columbia. Since that time has been marching steadily northward. Last I heard, they're in Chelan County. Cascades red fox, probably the rarest animal in our neighborhood here. John and I saw one driving over Rainy Pass a few years ago, and that's the only one I've ever seen, and we've had maybe 2 or 3 remote camera photos over the 30 years we've been running cameras in this part of the world. So not very common. They're more common, a little more common down near Mount Rainier, Mount Adams. And of course, hoary marmots. This is a little bit more common animal. You see these a lot on your summer hikes in the high country, but again, they're adapted to this high country environment that's at risk. One critter that's likely to benefit from climate change, much to most of our dismay, is going to be that one.
And that one is a rattlesnake.
So, where are we with time? Oh, we're about done. I want to point you to a nifty tool here. This is Audubon's developed this site where you can go in, pick a bird that's in your region, and they will create, it'll automatically create this map for you that predicts what's going to happen with climate change for that particular species. I was playing around with it the other night. It was a lot of fun. Take a look at that. A couple more examples. I'm going to spin through and turn it back over to Amy.
All right, I just wanted to cap it off. I'll keep it brief. I know it's getting a little late, and it is a school night. So if we remember, climate change is a human issue, right? Let's bring it back to humans really quickly. I heard some reactions from the audience who felt an emotional reaction to how climate change is affecting these animals. I know I did, right? I heard some ums and some ahs, right? So we have this emotional connection to these species. And so I think that's really important to really embrace and to act on. And so that's something that I'm really passionate about. Johnny mentioned that my focus is ecofeminism. A part of ecofeminism is this concept called ethic of care. So the way I like to think about ethic of care, a good example of it is, who here has been to a national park? Yeah, we're basically in one, right? Who here has hiked top of Maple Pass, Heather Maple Pass? Yeah, have you seen those ropes that have been blocking off sections of the trail, right? Saying this is for restoration. Yeah, and so what that part of you inside you goes, oh, it's a rule, I can't cross that rope. Or there's the other part of you that says, oh, I shouldn't cross that rope because this beautiful plant species right here, which is heather, could get destroyed if I walk on it, right? So that is an emotional connection that you have with that species where you go, oh, I do not want to harm that species because it might not grow back. So that it's just a really basic example of that difference between like, oh, I'm not supposed to do that, so I'm not going to do it. Or I'm not going to do that because I really care about that species. So that's something that I find really important, something I really strive to bring to education, especially to young people, to really facilitate that emotional connection. And so I really like to change the narrative, this colonizing narrative that we have of conquering the land, right? We conquer that mountain. We really, we're taking over this place. We can do this and that. 2, building empathetic relationships. I think empathetic relationships with the land is going to promote ethical stewardship. So stewardship is really important. I know that's a really key component to the Conservancy and to a lot of us that live in this beautiful place. Building those emotional and empathetic connections to those more than human species. And then I like this going from careful to careful, right? So we're full of care for this place. And this is an author that I really enjoy. She said, be driven by an appropriate environmental ethic, one that bridges relationships, focuses on connections, and applies simultaneously to the human and more than human world. And then, I know I ask myself this all the time, and I'm sure you do too, but we hear all this, we just saw a bunch of stuff about climate change that's affecting these local species. But what can we do? What actions can I leave here tonight and do? There's so many things, right? Every little step that we take, whether that's deciding to buy something that doesn't have plastic wrapping on it, to talking to a family member that maybe doesn't understand recycling. Talk about the importance of it. One of my favorite ones. Yes! Vote, right? So spread awareness and vote. Be conscious of your consumption habits. We are consumers. Be aware of what you're consuming. Also supporting conservation efforts. There's conservation efforts for all 3 species that we talked about tonight, as well as the additional ones there at the end. So supporting those efforts. And then I also really wanted to shout out to the Methow Valley Citizens Council. They're a local organization that has set up a climate action plan task force that is exactly tackling climate change in our valley, focusing on land and water and the people of this valley. So that is something to really support and to take a look at. The website has a really comprehensive section of sources that you can take a peek at. So highly recommend. So tonight, I really didn't want it, the goal of our talk was not to leave you feeling glum and sad that we're killing all the animals and destroying this earth, I swear. I really, really want to leave this message of hope, right? So we have the power and the ability to save these animals and to save this way of life. So that is my message tonight, is hope. And I really wanted to share a few little tidbits globally that are happening that are really hopeful. I hope you enjoy them. So we have, after being close to extinction in the 1950s, the humpback whale population has completely recovered. Yeah. Ethiopia just planted 350 million trees in 12 hours, breaking the world record. Yeah. Kansas City will be the first major U.S. city to offer free public transit. Yeah. Conservation efforts are working as endangered mountain gorilla populations are growing. The Irwin Family Hospital of the late Steve Irwin has treated more than 90,000 animals, many of them from the Australian fires. Phenomenal. Scotland will be powered by 100% renewable energy this year. The world is now past peak carbon per capita and emission rates are on the decline. So these actions that people are taking are actually working. It's amazing. Madagascar is to plant 60 million trees in the next few months. More trees, more carbon to oxygen. Florida is buying 20,000 acres of Everglades to protect it from oil drilling. And my favorite one, Diego, womanizing tortoise, single-handedly saved his species from extinction with his overactive sex drive. I think that's pretty phenomenal. And so with that, we are all concluded with this presentation, and we do welcome questions. Thank you.
No questions? Ken?
Amy, what's it like to work with your dad?
Terrible. Yeah, have her answer some questions.
No, he's the knowledge-based. Can you see why I went into wildlife? It's great. So actually working with my dad has been a really special opportunity. Not just our familiar relationship, but having a professional relationship. It's been great to challenge each other. I work in more of the educational theory, social justice end of things, and obviously he does wildlife management, so we kind of push each other sometimes. But it's really fun to work with him. I learn something new every day, and hopefully he learns something from me.
Absolutely.
I heard him say he or she at one point, and I was like, yeah.
Is that Melanie? Yeah.
I have another question for Amy. Could you explain ecofeminism?
Yeah, happily. So ecofeminism is a term that was really coined by a woman named Karen Warren. And so it describes the subjugation, domination, and treatment of land as it relates to women's bodies, particularly Indigenous women's bodies. And so liberating women as well as land from oppression. So that's kind of the crux of it. I focus a lot on social justice, environmental justice end of that, and like I said, the ethic of care piece. Does that answer your question?
Thank you.
I tell you what, you guys have been really patient, you've been here a long time. We're happy to stay and answer questions one-on-one, but I think we'll call it here, and thanks again for coming.
Thank you so much.
Well, that does it. Be sure and check out the Methow Conservancy if you haven't already at methowconservancy.org. You've been listening to Voices of the Methow, an off-the-wall production. Until next time, thanks for listening.